Hello everyone and welcome to another video of StudyRx. My name is Moses Pineda, a P3 student from Larkin University and the creator of StudyRx channel. And before I begin, I would like to say thank you for clicking on the link. I really appreciate the support. My Kappa Psi brother and recent graduate from Larkin University, Dr. Wilfred Asper, will voice this video. Now today's video is going to be on 7 topics involving medications or their class. I know Wilfred helped classmates learn medicinal chemistry by going over numerous concepts and much more, which made him perfect for this quick and basic review of oncology medications. Okay, now this video is a great tool that is useful to students who are going to be taking the course and want to head start reviewing some of the key concepts. This video may also be helpful to someone who took the course early on in their program or graduated and still find an interest in this type of material. So as you can see on the bar emerging from the bottom of the screen, these will be the 7 topics that we'll be discussing today. They are 5-fluorouracil, methotrexate, anthracyclines, camptothecins, tyrosine kinase inhibitors, vascular endothelium growth factor receptor inhibitors, and selective estrogen receptor modulators. Alright, now lastly, I want to remind anyone watching or listening, since I will be uploading this to my podcast, who this video is intended for educational purposes only. The information displayed was gathered by 2 students, us, and it's not even a quarter of the information we learned in our lectures. The book we reference is Foyer's Principles of Medicinal Chemistry, 7th edition. I listed the reference at the beginning of the video and at the end, just in case someone misses it. So thank you everyone. I will now hand it over to Wilfred.
Hi, my name is Wilfred Asper. I'm a graduate from Larkin University School of Pharmacy. These are some Spark notes that I used when I was a student here. All right, so we have Oncology MedChem. Hope you enjoy it. So for this class, one of the first things you probably want to know is that 5-FU has an irreversible reaction because it is linked to Michael reaction. And this is indicative of a conjugated double bond that's next to a carbonyl group. If you see that, you can pretty much assume that it's irreversible, as that's probably something that they like to ask. If you can identify the fact that it has a conjugated double bond next to a carbonyl group, it's pretty safe to assume that it is irreversible, and that they tend to ask a decent amount. So the structure of methotrexate is an interesting one because it has several important parts that you would like to know about it. The biggest one is being the tail, because the tail, due to its massive amounts of negative charges, it kind of keeps that inside the tumor cell. The other important thing about the structure would be the N4, which is this nitrogen up top. It makes the other nitrogen labeled as N1 more basic. So dihydrofolate is the top structure and methotrexate is the bottom structure. As you can see, they're a little different. They're pretty much flipped. This is due to the N4, making the N1 more basic, which means it kind of flips it. So the next group we're going to talk about is anthracyclines. So this type of drug, the way it works is it intercalates into the DNA. So a good way to remember what this looks like is it's literally 4 rings attached to each other. If you see 4 rings attached to each other, it's a good telling point that it's more than likely an anthracycline. You generally want your anthracycline to have few to no substituents because you're trying to fit it into the DNA, so you want less hindrances. So the less substituents you want, the better it generally is. Anthracyclines in general are pretty famous for cardiotoxicity as its pretty main side effect. So this happens because the drug itself concentrates in the cardiomyocytes, and this happens because the R group is reduced into bisphenol. So in order to combat this, people made the R group longer so that it takes a longer time to be reduced into that. So remember, small R group means it's going to be reduced to bisphenol quicker, whereas a larger R group means it'll take longer for that to happen. A shorter R group will generally get to that point of toxicity quicker, which is why you want the longer R group. Another important thing about anthracyclines is they're going to have a sugar on the bottom attached to it. This is basically so that it can bind to the phosphate backbone of the DNA. The next group we're going to cover is camptothecins, and they have a particular structure in them which makes them unique. It's called a lactone ring, and this lactone ring likes to open. It's very easily cleaved. So the active form of it is when the ring is closed. It's a full ring, but it's inactive when the ring is open. In general, a typical question that likes to be asked is whether you can identify an active versus an inactive form of a camptothecin. So just remember, active is the unopened ring or the closed ring, and inactive is when the ring is open. The next class of drugs we're going to talk about is TKIs. So I guess from my experience with this and from the class I took, one of the most important things to remember is the fact that they can potentially cause hepatotoxicity, and this happens when the structure has an amine group that's para to the oxygen on the structure, and that's what causes the toxicity. All right, the next thing I'm going to talk about is VEGFR inhibitors, one in particular, sunitinib. So this one, you want to keep it away from light because the Z isomer more potent than the E isomer. So cis, which is Z, is more potent than the trans, which is E. And it converts from Z to E in light, but will turn back when it's dark. The next class of drugs we're going to talk about are the SERMs. So there's two things that are important to this, is the aminoethyl side chain, which is essentially a nitrogen group that has carbons on it. The other important thing about this, about the drugs in this family, is you can see it. When it pops up, you'll know. It looks like a propeller or a fidget spinner. If it looks like a fidget spinner with an aminoethyl group, it's a SERM. So they'll ask you, that's something you might be asked as a potential question or so.
Alright, and that concludes this video. I hope the information was of some value to you. If you have any questions, please send them in via the comment box below. Don't forget to like, subscribe, and comment before heading out. And as always, share with your friends. Until next time, take care.